Hey guys, welcome back to new video of Code Freak. Yes, I have board exam tomorrow, so I won't be able to solve lead code question as it consumes a lot of time. So what I'm going to do today is I'll try to explain what single linked list is, how to add node at end, at beginning, and how to display them, and also how to delete node at any point. And let's dive into the problem. As we know, we can store list in our program in two different ways. One is using array, and another way to store is using linked list. Both of these has their own pros and cons. In array, data are stored in sequential memory block, so accessing data is faster, and also we can move or traverse in between array in both direction, as we can simply use the index, and it is easier to find the length of the list which is stored using array, whereas in linked list data may or may not be stored sequentially, as we use pointer to jump between each node. Eh, in The accessing of data is a bit slower, and there is no direct method of finding the length of the linked list, which is made using CPP. I don't know about other program whether they have their own built-in class or not. So I have to look how it actually works in programming language like Java, Python. But in C++, there is no direct method of finding the length of the list, which is stored using linked list beside going through each block. And the main advantage of linked list is that it is very easy to remove or insert node at any point. As in array, suppose you have five blocks in an array. We want to If we want to delete this block, then we have to shift each block forward. And if this array is made using uh, SMA or static memory allocation, then there is no for sure way of deleting this array beside uh, shifting each node by a single block, or each element by a single block, and the last block will remain empty, which is misusing of memory. However, in case of linked list, as each node is allocated using dynamic memory allocation or DMS, so it is very easier to remove node and also insert new node at any point. So without further ado, let's directly jump into the code. Today I will explain single linked list. Is I have five papers, and there is gap between each paper for 2 days. So what I will be doing is, for five papers, I will try to explain a programming concept in these 5 days, and in between 2 days, I will simply solve lead codes problem. That's what I am thinking. Okay, so let's start with singly linked list. It's better if we do in uh, ID. Uh, let's do it in online compiler. Okay, so what we need is, first we need to include IO stream for basic input output purpose, and we can simply use using nemesis std, so that we don't have to use std namespace in each object. Now let's make a class name node, where in public access specifier we have uh, two member. First one is for storing value. Let's name it val, and another is for storing the pointer of same type. And let's name it next, as it will be pointing towards next memory block. We are solving singly, or we are creating singly linked list, not doubly or cyclic list. I will do that in future videos. And now let's make a constructor of singly linked list, and the singly linked list will take value. In what we what we're gonna do is, we are gonna assign the value like this, and our next will at first point towards null, and that's it for the class. And we always have to remember that every single linked list will have a standard uh, class like this. We can simply create a member function for inserting a node or for deleting node. We can do that too, and we can also create a external function or independent function for deleting and inserting node. If we are using specifier, both option is viable. But I have already used public access specifier, so I would like to uh, directly directly create an external function. If I hadn't used public, then it would have been easier to uh, directly create a member function. But let's use external function as it is the standard way. Now what we need is we need two function name start sorry insert at end. Another function we need is uh, insert at insert at beginning. What we have to remember is there are various method of creating a linked list. From when I was learning, what I saw was uh, every tutorial video consisted uh, sorry, every YouTube tutorial videos showed me that what we have to do is we need a condition in insert at end to see if the pointer is null or not, or the head node is pointing towards null. And if it is null, then what we have to do is we have to use a different condition. But I don't like that way. What I like to do is we always insert the first node using insert at beginning, so our code length will also decrease, and it is very simple to understand. Is if there is no node, we simply insert at the beginning, and then we can either insert at beginning or at end. Both option is viable. So we need, as we know, if we, as you know, if we want to insert node, then what we need is the pointer pointing towards the head node. And another thing, what we want is the value. And as we are creating a new node, which, as you can see, we have written insert at end, which means that we are inserting a block. In order to insert a block, we need to first create a block, right? So let's create a block named n and use dynamic memory allocation. Uh, is it consists of a constructor, so we have to pass the value. And after doing this, we need to create a pointer, not a dynamic memory allocation. We need to create a pointer named temp, which is pointing towards head. This should be node, not nide. And now, what we have to do is we have to use a while loop and check while node next is not equals to null. Uh, Not node, sorry, that's quite bad. Node is the name of class, it should be temp. What we can do is we can move temp by a single block. And after we reach at the last temp block, now we can insert the value, which we do by using temp next equals to. And after completing the code and compiling, I'll explain each step what I have done. Uh, but I think you all can understand what I have done here. We have created a new node using dynamic memory allocation, and after that, I have assigned the address or the pointer which is used for pointing towards the head node, and assign that address to the temp pointer. After that, what I have done is let's say we have our linked list with two node, then our head pointer will be pointing here. I'm simply assigning the address present inside of head, which is the address of this first block to the temp block. Now temp is pointing here. Now we are checking if temp next is null. Temp is pointing towards this block, so this block next will be this block. So it is not null, so it will move by one step. And as we know, this is the last block, and every linked list always end with null. So we can see that the this block is currently pointing towards null. So the condition becomes false here. and it will come here. And what this while loop is doing is it will bring our temp pointer towards or to the last block present inside of current list. And as you can see, the name of the function is insert at end, which means that we are inserting the block at end. So now after we have come here, we can simply use the next pointer here to point towards our new block, and the new block is already pointing towards null here. So this is how we insert a node at end. And to insert a node at beginning, first we need to pass thread. Another parameter we need is of value. Now, as we know, inserting a node at beginning, we require a node. So what we need to do is we need to create a new node using dynamic memory allocation. After that, we can create a temp node for storing the address within inside of it. Now, what we need to do is we are inserting our node at it. As I have already explained how to insert node at end, now I'll explain how to insert node at it. Let's say these two are our node present inside of linked list, and this is our head, which is currently pointing towards the first block. So if we want this new block to be the head block, now what we have to do is we have to assign the next of this block here, and we have to assign head, or we have to make head pointer point towards here. And after we have done this, this node will be our new head node. But there is a condition is if a node or a linked list is empty, then head node will be pointing at null, which I will show you at last. And is head is pointing at null. So when we create a new block, what we have to check is if head is null. The step which won't change is that will be pointing towards the end. The step which will change is that now this block will point at nothing, which is null. It won't point at anything. So what we have to do uh, is if we change the value of head, uh, yeah, we have already assigned the value to temp. So now what we can do is now we can assign head to n, and we need to check if sorry, if temp equals to null. Uh, if it was pointing towards null, then what we have to make is we have to make, I think, yeah, we have already assigned it to null. So what we can simply do is we can simply return. And if not, if temp was not null, then we know that temp was it was pointing at something. So now we have to make and next to point towards that block, which address is present inside of temp is the value of head is already changed, and we are using a reference operator. So it means that the value of head in original block or from where the function was being called will also get changed. Sorry. And we are checking if the linked list was empty, then we will simply return by saying it will now point towards n. And if it wasn't empty, then the now new head node, which is n, will now point towards them. Now let's create a display function. Let me bring this a bit upward. So the display function will only take the head node, as it doesn't require value. We have already inserted value. What we are going to do is what we are going to do is uh, we're going to use a while loop. Sorry, before creating while loop, we need a pointer name temp as we don't want to change the value present inside of it. What we are gonna do is if temp is not equals to null, then we're gonna print the value present inside of temp and separate its value with a space so that the output will be a bit clean. And after printing, temp should be assigned to temp next or it will move each block forward. As you can see in this while condition, we are using temp next, and in this while condition, we are using temp null pointer, not equals to null pointer. Here we are using temp next because we want the loop to stop at the last node. Whereas in case of display, we need the pointer to reach the null, as we need to print each value. After doing this, the uh, program can simply return. Now let's create a main function where first we need to create a head node which is currently pointing to us now. As I already said here, if as I already said here, if there is no linked list, then head node will be pointing to us null, which is given here. Now what we can do is we can use insert at insert at beginning and pass the head node and also pass the value. Now we can use both insert at end and insert at beginning. Uh, let's copy paste the function. Okay, let's make this. If it is 2, then let's make it 3, then we make it 4, then make it 5. Then we can create a new function and insert 0 here. So now we can use display function by passing head, and we can simply return 0. Now what the linked list should do is it should first store 1, then it will store 2, 3, 4, and 5, and after that 0 should be started. 0 should be inserted in first, and it will print all of the block or all of the value present of node. Okay, so okay, instead of using equals to, I used hyphen. Yeah. Okay, so the linked list is working the way we wanted it to work. Now, the last thing we need is we need a function named delete. Okay, so delete is already a keyword, uh, or it is a operator. So what we need is let's make a function named deletion, and uh, we can either delete node in two ways by telling its position. Like if there are three nodes, then we can tell the program to delete the second node, or we can delete the node on the basis of its value. We can say that if the value of the node is let's say 3, then delete that node. We can do that in either way. What we are gonna do is we are gonna delete the node according to its value, uh, which uh, we need uh, is we are not creating any nodes, so we don't need to use dynamic memory allocation. What we need is a temp block, and another thing what we need is a pointer uh, using to delete, which is currently pointing towards null. Now what we can do is first we have to check if head equals to, it should be 2 equals to, and now what we will do is uh, we will check if head equals to null. Sorry, if head equals to null, then we can simply return. without doing anything. Else, if head is null, then there is no any uh, value to delete. And if the head is not null, then we can proceed ahead. And now what we have to do is we need another condition using if head. Uh, okay, so instead of using head, it is better to use temp here. If temp value or the value present inside of first block equals to the given value, then uh, uh, we can simply assign head to temp next is the node which is to be deleted is this node, and can assign to delete to temp and delete temp and return. But uh, okay, let's not do return. Uh, or we could do return. But I guess instead of using if, let's use while loop. Uh, is if we consisted of a linked list with same value, then we need to delete all of the value, right? Just like what we did yesterday in the program. So we can use while temp next, as we already know, temp is okay. Well, checking a value presentation of temp value equals to the given value. Then first what we need to do is we need to move head by a block. After that, what we need to do is we need to assign to delete, not to null, to temp, and after that we will delete the to delete. Okay, so this will only happen if the value present inside of first block is value. So instead of using it, it's better to use temp here. Uh, and after the loop has completed, all of the node which is to be deleted will be deleted, right? And after that, uh, okay, so if we are using temp here, then the we need to assign to delete to temp before assigning temp to temp next. Okay, so after completing this one, what we need to do is we need to assign head to temp. Okay, so what we are doing is we are checking whether the value present inside our first block is the same as the given value. If it is, then we are deleting that block and also moving our temp with temp or single block ahead. And again, we are checking whether the next block also consists of that value. And if yes, then it will be deleted. And if not, it will come here. And we will assign head to the temp. After that, after that, again, what we are gonna do is well, now what we need to do is we need to use temp next value. If temp next value equals to the given value, then we will delete it. Why we are using temp next is that we have already checked the value. Let's say the value we need to delete was 2, and this was our nodes. Let's say the first node is 2, second node is 2, third node is 3, and fourth node is 2. Then what will happen is first node will be deleted using the first condition. Again, as we are using while, so the loop will continue and this node will also be deleted, and we are comparing this value, and if this value is not equal, then we are exiting. So now we have already checked the condition or the value present inside of 3. Now we have to check next values. So we need to use temp next value. Also, it is better to use temp next value as we know the pointer is in single linked list. We cannot traverse in backward direction. So in order to access the pointer present inside of here, sorry, access the pointer present inside of here, uh, it's better to use temp next. Okay, so before using this, we need to use temp list is not equal to null. and it work. Yeah, if template is not equals to null, then before accessing template value, we need to check whether template is null or not. If it is a null, then we can check the value. Okay, so uh, I think we need to, yeah, before we need to check whether temp next is not null. If it is null, then there is no point in checking the program. And if it is not null, then we need to check the value present inside of temp next equals to the given value. And if it is uh, the same value, then we need to assign to delete to uh, temp next, or sorry, temp next to delete. And also we need to use temp next to uh, temp next. And after that, we will delete, not equals to, we will delete that to delete. After that, and if the value was not equal, then we can simply move by a single block. If the value is equal, then we need to remove the node. If not, then we can simply move by a single block, and it's better to put it inside of else. Yeah, so if the value present inside of next block is equals to the given value, then that node will be deleted, and next will now point towards a block which is void of the node which is to be deleted. Else, it will simply move by a single block. So what now we can do is also let's use cout endl. Now our function name is deletion, right? So what we can do is deln. Okay, will it work for the last block? Okay, so uh, let's say that uh, let's say the node to be deleted is one, and we have three no, sorry, we have two nodes, and the last node is pointing towards null. So first this will be deleted. Okay, instead of two node, it's better if we use a bit of uh, node. Yeah. Okay. So first one will be deleted. We will check the condition for three. As three is not equal, so we will come towards this downward loop. And this loop will check the value present inside of two. Right? As this value is not equal, so we will simply assign temp to temp next, and we will then check while temp next equals to null pointer, and you can see the node the value is 2 is clearly pointing towards null, so the loop will be false here, and then we can simply terminate this function, right? However, if the block is inside of this one, then as the value is equal, will come inside of here, and to delete will be assigned to one will be assigned to delete, and now temp next will point temp next which is this block, temp next which is this block, and after that we will delete this, and as it is inside of else block. Now we are checking if temp next is not equals to null, but as you can see, it is clearly null. So if temp, what we need to do is now, okay, so uh, we need a new condition here. If temp is not equals to null pointer and temp next is not equals to null pointer, we need this condition. As we can see now, temp next is pointing here, so it's better to put temp is not equals to null pointer too. Now let's delete 0, which is currently our first node. So we will know whether it is working for first node or not. After that, let's delete the middle block, which is 3. Now we'll know whether it is working for general block or not. After this, let's delete 5. Now we'll know whether it is working for last block or not. Now we can simply display the link list. If it works, then it will display 1, 2, and 4. Yeah. So it is working. That's it for today. Thank you for watching. Tomorrow I will solve lead code question. Uh, Tomorrow I have to give board exam, or it is first paper of my board exam. I wasn't able to make a full-fledged video today, but however, the length of the video is already 30 minutes, so that's it for today. Okay, I will end the video right here for today. Thank you for watching.